Hi everyone, my name is Katharine Lauren.
My name is Vanessa Natalie. In this video, we are going to explain our experiment about characteristic of graphene composite mixture resulting from electrochemical exfoliation with a gypsum hardening process in an electric field.
This research aimed to determine if these exfoliated graphene flakes are effective for electrical conductivity that can be practically applied in energy applications.
Many people spend batteries generating waste, but this idea offers a way to be recycled and convert them back into energy.
A crucial component of the batteries is the carbon rod, has a potential to conduct electricity even without the electrolyte. Nowadays, carbon is still a material that continues to be extensively researched, with new applications constantly being discovered across various fields, including electrical technology.
This research investigates the potential of combining the exfoliated graphene flakes with gypsum to create a conductive material. In earlier study, the conductivity of gypsum was developed by the use of a polymer known as polyaniline.
Combining alpha and beta gypsums with polyaniline in vitro conditions produces an electrically conductive composite for chemical, military, and electronics applications.
Graphene is a two-dimensional material or a single atomic layer of sp2 hybridized carbon atoms arranged in a honeycomb structure with high intrinsic mobility. A high-yield electrochemical exfoliation method has been created to synthesize high-quality graphene flakes, with the carbon supply being graphite rod produced from wasted zinc carbon or pencil core. Other researchers have discovered different ways from conventional parallel to electrode by using platinum wire for the cathode, which is positioned vertically at the bottom and the top of electrochemical cell, and the zinc carbon primary battery as the anode. Different aqueous solutions of protonic acids such as sulfuric acid, phosphoric acid, and oxalic acid were selected as the electrolyte to optimize the exfoliation process.
Gypsum is a result of calcium sulfate crystallization in monoclinic system. Gypsum is a highly soft mineral that can be recognized by its water solubility, cleavage, and hardness. Because of the ionic connection between the cationic and ionic radicals that make up this salt, gypsum has low electrical conductivity because there are not any free electrons in it. Electric field is the force that fills the space around every electric charge of a group of charges, and it is caused by electrical forces. There are two types of electrical fields, the static field and dynamic field. Whenever there is a voltage and a distance between electrodes, an electric field must be generated. Voltage and electric field strength are related according to this equation. Using the electric field, the resistivity and conductivity of the material can be determined using this formula.
In order to get the graphene flakes, a carbon rod from a used battery was utilized as the anode and a stainless steel roller as the cathode. The carbon rod was electrolyzed using sulfuric acid with a voltage of 7 volts and a current of 2 ampere. To make the carbon gypsum, we need graphene flakes, gypsum powder, water, and gypsum molds. In this study, there are 5 different percentages of graphene flakes in the overall mixture of water and gypsum. Specifically, gypsum without graphene flakes, 2%, 5%, 10%, and 15% of graphene flakes. The graphene flakes are added to the gypsum and mixed. Water is also added with a ratio of gypsum and water 10:7. After mixing, the mixture is poured into the gypsum molds, then let the gypsum for 2 days or so until it has hardened.
Each combination of carbon gypsum is made with 2 different treatments. One is given an electric field for 1 day and the other is not. To generate the electric field, a voltage up to 190 volt and frequency of 50 kHz was applied from a single generator. Using a step-up electrical transformer, the voltage is sourced from a 10-volt source. The ratio of primary coil and secondary coil in the transformer is 1 to 18.5. As a conductive coating, carbon glue is applied on the both 4x4 cm side of gypsum. The carbon glue is made of graphene flakes and white adhesive glue with ratio 6:1. Conductive coatings are materials applied to surfaces to increase electrical conductivity. Conductive coatings work by reducing electrical resistance and allowing for efficient current flow. Next, a digital multimeter is used to measure the resistance of the samples.
In this experiment, only the 10% and 15% carbon gypsum can be measurable with a multimeter. The gypsum without carbon, 2% and 5% carbon gypsum were all unmeasurable, indicating the conductivity is lower than the measurement limit, which was 0.0031 per mega ohm centimeter. Among all the samples, the electric field gypsum with 15% carbon has the highest conductivity.
The result shows that applying an electric field to the gypsum can produce more resistance. In comparison to the non-electric field gypsums, the 10% carbon electric field gypsum produces 80% resistance, while 50% carbon, the electrical field gypsum produces 40% resistance compared to the non-electrical field. With the cross-sectional area of the material 60 cm squared and the length of the material 1 cm, the resistivity and conductivity of material as follows in the table.
In conclusion, the experiment can show that gypsum and carbon, specifically graphene flax, can conduct electricity. By increasing the percentage of carbon and applying an electric field, the resistance is reduced and the conductivity is enhanced.
More research is still required to develop this carbon gypsum. A thinner sample shape may give better measurement results. In addition, we could try using a 4-point probe method to measure the resistivity and conductivity of the gypsum. That's all from us. Thank you.